In this example, we're going to solve this linear system using substitution. So the first step of substitution is to choose one of these equations and then solve that equation for one of the variables. So typically the strategy is to find a variable in the system that's easy to isolate. So typically speaking, its coefficient will be either 1 or -1. So I notice here this y has a coefficient of 1, while the rest of our variables have coefficients other than 1 or -1. So I'm going to start by solving for y in that first equation. So 4x plus y equals -5. So in order to solve for this y, we're going to subtract 4x from both sides, and y will end up being -4x minus 5. So what this tells us is that the variable y is equivalent to this expression, -4x minus 5. So whenever I see a y, I could substitute in -4x minus 5 in its place, which I'm going to do to the y of the other equation. So I'm going to go ahead and drop this -4x minus 5 into this y, but in the other equation. And in that manner, we're going to combine these two equations together. So what that looks like is -3x minus 2y equals -5. And we're going to substitute in for y this expression, -4x minus 5. And then it's just a matter of solving for x, since now I have a single equation and a single variable. So I'm going to use my distributive property and get positive 8x plus 10. Combine my like terms. Subtract 10 from both sides. And it looks like x equals -3. Now that I have this value for x, I'm going to go ahead and plug it back into one of these equations to solve for y. But what equation will be the easiest to get the value for y? Well, right here I've already done the work. Y equals this expression that contains x. So if I know what x is, I can plug it in right here, and whatever I get when I evaluate that expression right there will be the value for y. If I was to plug in x in either of these equations, I would have to do some work again to solve for y. But the work's already been done, so I'm going to plug it in right here. So y equals -4 times x, and x is -3 minus 5. So y equals 12 minus 5, and y equals 7. So in solving this linear system, I find that the solution is the ordered pair -3, 7, which means that the ordered pair -3, 7 is the only point that will be solutions of both of these equations. And if I were to graph these two equations, the point of intersection would be -3, 7.